Recently, I needed a software to log and monitor multiple serial ports at once. I did not find one that I liked, so I made it myself. The software is open source, and here is a quick demo. This combo box will show all your connected serial ports. Here I'm connecting my CNC, which runs on an Arduino. Once it is connected, the new port will show up. Now I can check this box to send messages to that port. As you can see, the machine is replying correctly. Let's try to connect a second user. In this case, an ESP32 that just sends sinusoidal waves with a different phase. Now we can plot these signals in real time. To do so, select how many inputs you expect to have and hit the graph button. Each graph will be opened on its own window. You can then decide to click this button to look for a pairing window. Once two windows are looking for a pair, they will merge and create a merged plot. The inputs do not have a predefined separator, just make them non-ambiguous and it should work. You can also set the time window. With a different button, you can still recover the original graphs. There are also additional controls to change how data is displayed. One more feature is logging the data. By selecting the log checkbox underneath a port and starting the log, the program will save the data into a folder. In case there are multiple logs, you will get both a log of the single port and the combined log of all the ports. You can also decide to log the user input. The last feature is scripts, of which there are two types. The first type is a reply. You can set a keyword and a message. When the software reads that keyword from the specified ports for the input, it will reply with a predefined message on the specified ports for the output. The second type simulates a keypress, in case it reads a specific keyword on the specified ports. Some info about the syntax for the scripts can be found on the GitHub page. Depending on the board, it can also detect if it is disconnected. Here is my use case as a pretty interesting demo. I want to log the vibration of a spindle. The ESP connected is reading the data and computing mean and variance. Each time I receive a G-code line from the CNC, the computer replies on the ESP port, that then replies with the computed values and restarts the count. This allows me to know variance and mean associated to each G-code command. And here it is in action.